Here's a puzzle that looks impossible at first. You have a .then handler that returns a promise. That's completely normal. Promise chains work by returning promises from handlers. But what if the promise you return is itself resolved with a promise, which is resolved with another promise, which resolves with another promise, infinitely? Is this even a valid thing to happen? Can a promise chain resolve infinitely? The answer is yes, and the consequences are severe. The promises/a plus specification says that when a .then handler returns a thenable any object with a .then method, the promise machinery calls that .then method to determine what value the outer promise should resolve to. This resolution process is recursive. If the returned thenable itself resolves to another thenable, the process runs again. In theory, this recursion has no bound. In practice, creating an infinite recursive resolution chain is a memory leak. Each unresolved promise in the chain holds a reference to the next, and none of them can be garbage collected because they're all waiting on each other. Your process's heap grows without bound. Eventually, Node.js runs out of memory and crashes. In the real world, this situation usually arises from a mistake. A function that is supposed to return a plain value accidentally returns a promise from a .then handler instead. Or a recursive function that builds up a chain in a loop. The bug is subtle because the code looks correct and runs without throwing any error, it just leaks memory silently until the process dies. Now that we understand how infinite recursive promise chains happen, let's talk about how to avoid them and, more importantly, how to recognize when you might be creating one. The most common trigger is an accumulation loop. You have a loop that runs many times, and each iteration chains a .then onto the previous result. If you write this naively, you're building a chain with as many links as loop iterations. For a loop that runs thousands of times, you have 1,000 promise chain all held in memory simultaneously. The fix is to avoid building chains in loops. Instead, use promise.all, with a mapped array, all promises created simultaneously and resolved simultaneously. Or use a sequential pattern with async/await and a for of loop. Each iteration awaits the previous, creating no persistent chain at all. Another trigger is recursive functions that return promise chains. If your function calls itself and chains the recursive call onto its return value, the chain grows with each recursion depth. The fix is to use async/await recursion with await instead of .then chaining. Each await resolves the chain at that point and starts fresh. The stack-like structure of async/await recursion handles this correctly where .then recursion does not. The practical rule the book derives from this is, use .then for flat chains where you know the total length. Use async/await for dynamic, recursive, or loop-based patterns. The syntax difference is not just aesthetic. Async/await has superior runtime semantics for patterns that generate large numbers of async operations. Chapter 5 covered a lot of ground, and it's worth a moment to consolidate what you now know. You started with the promises/a plus standard and the 3 states of a promise. You learned the full API, then, catch, finally, and the 4 static coordination methods: promise.all for fail-fast parallelism, promise.all settled for exhaustive parallelism, promise.race for first win scenarios, and promise.any for first success scenarios. You learned permissification, both the manual pattern and util.permissify, as the migration strategy from callback land to promise land. You understood sequential execution as a flat .then chain, parallel execution as promise.all, and limited parallel execution as a task queue class. Then async/await showed you how all of this can be written with the clarity of synchronous code. You saw the return versus return await distinction, the for each anti-pattern, and how parallel execution with async/await is still just promise.all under the hood. And you ended with the infinite recursive chain, a pathological case that reveals important truths about how promises work at a low level. What comes next in the book? Streams. Where callbacks and promises handle single results or sequences of results, streams handle continuous flows of data, reading a large file without loading it all into memory, piping HTTP responses directly to disk, transforming data in real time. The patterns from this chapter, sequential, parallel, bounded, all apply to streams too. You've built the foundation. The next chapter puts it to work on data flows at scale.